All right. Okay, 34. In fact, many of these are like going to be on tomorrow's quiz, like this right here. Exactly.
Like multiple choice?
No, I mean the problems itself. Like what I'm gonna, okay, look, this is what okay, if I give you this problem on tomorrow's quiz, you gotta change it to a rectangular equation and draw the graph. That's what you gotta do. There's no like pick it out, you gotta actually draw it. So multiply both sides by r, like we have done I don't know how many times. Hey, you somebody. Hey, you somebody. And then you complete the square. Y squared minus 2y, leave a space. And then add 1, and then you got x squared plus y minus 1 squared equals 1. Hey, you encircle. Now you gotta draw the graph. The center going to be at 0, 1, and the radius is the square root of that number, which is 1. So, that's what you're gonna do tomorrow.
Maybe.
Not like pick out the answer. The answer going to be G.
Mr. Park, for tomorrow's quiz, are you giving us the graph paper and just free draw it?
Yeah, because you're changing it to a rectangular equation.
Okay.
So you just gonna graph it in the regular rectangular way. You don't need polar graph paper tomorrow. Or do you? Well, if you do, I will provide it on the quiz. Well, I just thought of a problem I could put up, but I'm not. 36. R sine theta equals 2. R sine theta equals 2. Hey, you somebody.
What?
That's y. Y equals 2. Hey, I know how to graph that. That's a horizontal line 2 units above origin. Finished. You guys can do that, right? Anyway, though, just do the practice quiz. It'll be almost exactly like it. They should do. Look, all of these are there. These are all on the practice quiz right there. Okay, next, or is that it? What, okay, now what about the hard one? So am I doing both?
Yes.
Boo! How about just one of them? Oh yeah, I'll do both. That's what I'm getting the paid the big bucks for, right? It's not too often a teacher can make $3.7 million a year plus endorsements. That's why I shouldn't grumble about doing extra work.
I'm sorry, do you get paid extra for doing for the...
No, because I'm getting endorsed by TI calculators, that's why, so.
Not even...
That's an additional like $625,000 a year.
For this...
So what's the question?
Dude, his face is so straight when he said it here.
Okay, now I'm looking at this problem. Wait.
It's an extra...
Shh, I'm trying to think. 1, negative 1, 3. See, I can tell already, whoever wrote this problem is not thinking of the student. Because, okay, for those of you who did the problem, did the numbers come out nice? No, see, this way, don't worry. I don't know.
We did.
If you want to make this problem come out nice, you would make that number up there a 3. That's what I would do, but this person made it a 2, and now all hell is breaking loose. But that's okay, we're going to do it, because fractions builds character, right? Okay, cross multiply. R minus 2r cosine theta is equal to 2. Hey, you somebody.
What? Oh, X, I'm sorry.
You guys keep making that same mistake. It's x. No, cosine is x, sine is y. That was from the first time we learned trig, right? Cosine is the x, sine is the y. And then what do you do? Because we need to have r squared, right? So what do? Isolate the r. No, not yet. We isolate the r. So r equals 2x plus 2, correct? Now you square both sides. R squared is equal to, in fact, I gotta skip a step. R squared, we already know is x squared plus y squared, right?
Mm-hmm.
And then if you square this, 4x squared plus 8x plus 4. Now, right now, you can't tell if it's an ellipse or hyperbola yet, like the book told you. I'm not going to tell you either. You have to complete the square to see. So what do? You put all the x terms together, so if you move it on this side, you're going to get 3x squared plus 8x. Put the y minus y squared, bring the number to the other side like that. It doesn't matter whether you put it on the left or the right, just pick one and go with it. Okay, now, see? Ugly. What can be factored out from these two numbers? You always have to factor out the coefficient of x squared, so you have to factor out that 3. But see, that's going to leave you with 8/3. It's becoming ugly. See, if I were me, but
You are you.
but if I were me, this thing would be coming out whole numbers. Anyway, so what do I have to add right there to make a perfect square? You take half of that and you square it. What's half of 8/3?
4/3.
4/3 squared. 16
9.
over 9. But what did I actually add? 3 times 16 over 9, which is
Ugly.
16 over 3. Terrible. Terrible. Okay, and then if you gotta add these two, you gotta make a least common denominator, so that's like negative 12 over 3. So what does that come out to? 4/3. Now, remember, when you're doing ellipses and hyperbolas, you want this side of the equation to be 1. So how do I make that side of the equation 1?
Multiple both sides.
Multiply both sides by 3/4 or divide by 4/3? What's your preference? Okay, multiply both sides by 3/4. So this is going to be multiplied by, this whole side got to be multiplied by 3/4. So, how are we going to get that? So this is going to be x plus 4/3 quantity squared. Now, what happens when I distribute the 3/4 over here? You're going to get 9 over 4. Oh, that's a minus. Minus 3/4 y. So y squared, rather. Now, is this standard form? Look up, this is horrible. Who wrote this problem? So, what do I do? How do I, you can't have the 9 here. So how do I get rid of this 9 up here? Multiply top and bottom by 1/9. So you can get this. This is just horrible. Multiply this by 1/9 and you get 4 9s. Well, at least they made it so you can square root it. That's terrible. But this one, bad, because how do I get rid of the 3 there? You gotta multiply top and bottom by 1/3. So on the bottom would be 4/3. Why don't I put parentheses around? See, look, that one you can square root it, but that one is ugly. It's terrible. Don't worry. You know I'm gonna make nice numbers. Okay, so, is this a hyperbola or an ellipse? That's a minus sign in between. It's a hyperbola, minus sign. So, what's the center? Negative 4/3, 0. What's going on? Negative 4/3, 0, that's the center. Now, how much do I go left and right? You look at that, the square root of that number. What's the square root of 4 9s? 2/3. So, you go 2/3 to the left and 2/3 to the right. That would be about there. Is that about right? Negative 4/3, so 2/3 and 2/3. That's about right. Doesn't look right though. It's because it's just make the dots bigger. What's the square root of 4/3? Oy. I don't know. Just 1 point something, I guess, right? So from the center, you go 1 point something up and 1 point something down. So just go that and like that, and then you make the rectangular box up. Now, if this was a plus sign, you just go like this. Woo! It's an ellipse. But this is a hyperbola, so you have to make the rectangular box like this. Then you draw in the asymptotes, which are the diagonals of the box. And then, if the x1 is first, is it left and right, or is it up and down?
Up and down.
Wrong.
Wrong.
You guys 50-50 chance. There. That's the graph. Mr. Parker, just gonna skip this problem. No, but I'm gonna make it come out nice. Don't believe me. If you do it correctly, you're gonna see a whole number there, and you're gonna see nice square numbers here, like 9 and 16. That's how I'm gonna make it. Or maybe not. Okay, do we have to do 67? You sure?
Let's do it.
But did the answers come out nice? Let me look. No, it's ugly!
Can we skip it? then?
No, can I change the number? Did you guys do the problem?
That's
I honestly
super
do not.
random.
I know. Okay, you know what? I want to do the ugly numbers because it builds character. Okay, so 67. You know what? I should have screened these
Are we
problems.
gonna continue like these like 66 and 67 problems for like tonight?
No, I don't think, tonight's homework, I think I only assigned between 37 and 60, yeah? Or 37 and
So
64.
are we gonna get practice with these, like, with the nice numbers?
Yeah, don't worry, on the practice test.
Oh,
Yeah. Come on, you guys know already. If it's not on the practice test, it's not on the test. If it's in the game, it's in the game. Or do they still have that commercial? For EA Sports.
Oh,
You guys play video games.
Justin does.
Okay, now if I were me, if I were making this problem, see 1, 3, and 5, I would put a 15 up there to make it nice for you. But they got a 1 up there, so we gotta deal with it. Cross multiply. Except I did it wrong. 3r minus 2r cosine theta. Hey, you somebody! What is that? Okay, finally we're getting it down. Isolate the r term, so move this on that side, so that's gonna be 2x plus 1. And then you square both sides. So this becomes 9r squared is equal to 4x squared plus 4x plus 1. Are you guys did at least this though, right? Okay, and then, hey, you somebody. So if you distribute the 9, you get 9x squared plus 9y squared. So 4x squared plus 4x plus 1. See, at this point, if either the x squareds or the y squareds canceled out, it's going to be a parabola. But they didn't, so now you know it's going to be ellipse or hyperbola. So, put all the x's together, so bring it over. 5x squared minus 4x. So you can tell already, if you factor out a 5, you get fractions. Plus 9y squared equals 1. Who would even do this? They're a monster. Okay, factor out the 5. Now, if I factor out the 5 from this, what are you going to get? 4/5. Ew, that's horrible. Downright horrible. Okay, what do I have to add right there to make a perfect square? You take half of that number, which is negative 2/5, and you square it.
4 over 25.
4 over 25. But what did I actually add?
5.
5 times that, which is 4/5. So add 4/5 to both sides. So, what do I have now? 5 times x minus 2/5 squared plus 9y squared equals, what is 1 plus 4/5? 5/5 plus 4/5 is 9/5. Now, we want this number to be a 1, so what do you want to do? Divide by 9/5 or multiply by 5/9? It's the same result. Okay, multiply both sides by 5/9, so you're going to multiply this whole side by 5/9 too then. That's how you get the 1 over there. Okay, now, what happens when you distribute this 5/9? You can get 25/9 times x minus 2/5 squared plus, distribute the 5/9, you get 5y squared. The 9's cancel out. But this is not standard form yet, because standard form, you cannot have, the coefficient over here has to be 1. So, gotta be like this. So how do I get rid of this 25/9 here? This is like over 1. Multiply top and bottom by, how do you get rid of 25/9? Multiply by 9 over 25, so 9 over 25. Same thing here. How do I get rid of this 5? Multiply top and bottom by 1/5. That's terrible. And well, at least this one you can square root it. Okay, what's the center of this ellipse? Wait, by the way, how do I know it's an ellipse? Because there's a plus sign there. Okay, how do you find the center? 2/5, 0. So 2/5 would be about there, 0.4, yeah? 2/5, there's the center. Now, how much do I go left and right? You take the square root of that number. What's the square root of 9/5? 3/5. So you go 3/5 to the left and 3/5 to the right. What's the square root of 1/5? Oh gosh. Don't tell me.
You did.
0.447. Somebody confirm that. Square root of 1/5, 0.447. I just want to see if I still have it.
Then you have to do it on the board.
Just because I'm not young anymore.
Point four four
See?
2
Take that! So you go 0.447 up and 0.447 down. and then you just draw the ellipse. Woo! Finish. I just see. That's why. I should just write my own problems. This is terrible. Okay, now today I'm gonna teach you the shortcut for graphing. Okay, but in order to do this shortcut, you gotta like memorize certain forms. See, that's the thing. Otherwise, you either got okay. These are the two techniques of graphing. You make the chart like I showed you yesterday. That might take you 15 minutes just to make the chart, and then you gotta plot the points and connect the dots. Or you change it to a rectangular equation like you did on last night's homework. But then you gotta make sure that rectangular equation is something that you know how to graph, right? So now these graphs come up very often in mathematics. So pre-calculus and calculus, these graphs are going to be important. So some of you are thinking of majoring in engineering or some science. If you get a Bachelor of Science degree, you need 2 semesters of calculus in it. Anyway, so let's do this one. First of all, the circles. Anytime you see a graph that looks like this, r equals a number times cosine theta, just like last night's homework, r equals a number times sine theta. Now remember how you did it on last night's homework? Like, I just did it on the board here, like r equal to cosine theta. Remember what we did? Multiply both sides by r, okay, use somebody, complete the square. Okay, yeah, you can do that, but now, anytime you have an equation like that looks like this, it's going to be a circle. Okay, let's go to the graph. Okay, so we need to get rid of these. How do I get rid of that? Delete, bad. Get rid of that. Delete, bad. Okay, now I want polar graphing, so that would be r equal. Okay, so I'm going to type in r equal. Okay, so what happens when you see r equal, give me a number, any number.
15.
Oh, that's too big. Huh?
6.
Okay, 6 cosine theta. Okay, let's check, let our calculator do it. R equals 6 cosine theta. Bam. Okay, now what kind of window do we want? Let's go standard. Okay, execute, draw. Mr. Park, you said it was a circle. That's because the scaling of the x and y are different. So, you know what we should do? V window square. I don't even understand that. What does this mean? Oh, I get it. Why, please? No, I don't get it. Well, let's just see. There, now the circle. Now look at that circle. What's the significance of this number right here?
Stretch.
No, it's a circle.
Oh,
It's the
x-axis.
no, yeah, I know. It's the
The radius.
no. Look at the picture.
Diameter.
Thank you. It's the diameter. This number tells you the diameter of the circle.
The radius times.
In fact, can you see a pattern to this? Okay, you know what? Why don't we draw 4 so we can see the pattern? Okay. Now let's graph. Let's do a negative number. How about negative 4? Where's cosine? Cosine theta. Okay? Go. Go.
It's on the other side.
Oh, when you put a negative number, it's on the left. Oh, I get it, Mr. Park.
You somebody.
Because
No,
it's
you
2,
said
its
I-
diameter is 4.
Okay, now let's do some sine ones. How about 5 sine theta? And then how about negative 3 sine theta? I think by graphing these 4, you're going to see a pattern.
Up and down.
Hey, you somebody.
Okay, so the blue and the red ones were the cosine ones. What do you notice?
On the right and left, or the x-axis.
The diameter lies on the x-axis. What about the green and the lavender one?
On the y-axis.
Oh, Mr. Park, I see the pattern. Do you guys see the pattern? I see the pattern. Do you see it? Okay, so what you have to do, so now that we've seen the pattern, r equals 6 cosine theta. See, you have to become the calculator. So, cosine theta, what?
That's on the
1, 2, 3, 4, 5, 6. Finish. R equal negative, give me a different number now. Negative 2 cosine theta. So you just do this. See, the cosine ones are to the left and to the right of the y-axis. The diameters lie right on the x-axis. That number in front tells you the diameter, and if it's positive, it's to the right of the y-axis. If it's negative, it's to the left. You see the pattern? It's a pretty easy pattern, huh? Okay, what about the sine ones? What if you had to grab r equal, give me a number, 7 sine theta? What would you do? You would do this. 1, 2, 3, 4, 5, 6, 7. Circle. What if you had r equal negative, give me a number?
11.
No, let's keep it below 10, people.
1, 3.
Okay, 3. Negative 3 sine theta. Why do you guys pick the bizarre one? 1, 2, 3. Nyeh. You guys sure you see the pattern? No, if you don't want to, like, I don't want to learn the pattern. If you don't want to learn the pattern, then go change it to a rectangular equation like you did in the last night's homework, or make the chart. Why is there crinkling? You guys can eat, but no crinkling.
Fucking drag it. Here.
Chun, is that your seat?
No.
Why do you keep moving?
So I can see the calculator.
Okay, so does everybody, so you know it's a circle when you have r equals a number times cosine theta or a number times sine theta, because on the test, it's all gonna be mixed up, you know. I'm not gonna tell you, this is a circle. Well, you want me to?
Yeah.
Okay, you want me, but I'm not gonna. Because on the final exam, you gotta know, you have to recognize certain forms.
Who's making the final exam anyway?
What?
Who's making the final exam?
Mr. Sasaki,
Um,
it's already made.
How come not you in this part?
Because I'm not the captain for Trig, I'm the captain for pre-calculus honors.
Oh, so you made the test for pre-calculus?
Yes.
Let's do the admiral.
What?
No, Sasaki. That is
Of course. Of course. Okay, now, next one. R equals a number plus another number cosine theta, or R equals a number plus another number sine theta. Okay, when you have equations that have this form, these are called the limosons.
How do you say that?
Limoson.
Lima.
This is a French thingy. Who takes French here? Somebody got to take French, right?
No, in next class.
Okay, anyway, when you put this, whatever thing it's called, I took French and I don't really know. It's a, you pronounce it sa. Because I've heard some teachers call this limacan. You go to college, you say limacan, you can be laughed at in the dormitories. It's limoson, it's a French word.
No.
Okay, now there are 3 kinds of limosons, okay? Depending on what these 2 numbers are. Okay, let's go to the board. Okay, how do I delete this? Doot, 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 doot. So if you're watching on the video, you gotta punch it in on their graphic calculator, or just watch me draw it on the board. Okay, so what if you have something like this? 2 minus 2 cosine theta. Notice how A and B are equal?
Mm-hmm.
Okay, let's look at the graph. Oh. Okay, this,
What?
okay, so let's classify it. So if the absolute value of A equals the absolute value of B, what you get is a cardioid, because it's a heart-shaped thing. It looks like a heart.
It's not.
And it looks like this. Okay, what was the graph I just put on the board? 2 minus 2 cosine theta. So it's gonna look like this. Looks like that.
It's not a heart though.
No, a heart shaped. That's why cardioid is called a. Yeah, but every year there's always students go, Mr. Park, it looks like a butt, and it's going to the east. Well, if that's what it's gonna take. Okay, so whenever the absolute value of this number equals the absolute value of that number, it's gonna be a cardioid. Okay, now let's look for the patterns in the cardioid. Now let's do another one. Let's do a sine one. How about 3 plus 3 sine theta. Okay, let's graph it. Let's graph it.
It's a butt going
Oh,
down.
it's a bigger butt, now it's blowing to the south. Yes, well, if you want to think like that, the cosine ones blow east and west, and the sine ones blow north and south.
Some Kim K. Yeah.
What?
I didn't say nothing.
Okay, but okay, you know what? I'm gonna put all of these together at one time. I'm gonna just boil it down. See, I bet you none of the other teachers are gonna give you the shortcuts I'm gonna give you. So then you can help all your friends and charge them. When your friends say, "Can you help me with this polar graphing? I'm having a hard time," and then just teach them my shortcut. And then make sure they pay you. Though. Make sure they pay you.
I'm gonna sell the practice final exam.
Say that again for the camera.
I'm gonna sell the practice final exam. $10 a piece. 808 729
Sit down,
292.
John. R equals. Okay, now what would happen? So whenever, like I told you, the absolute value of this number equals the absolute value of the number, you're gonna get a cardioid, a heart-shaped thing, or if you want to call it the butt. Actually, you don't even have to know if it's going east, west, north, or south, because I'm gonna teach you something, so you don't need to know. Okay? Okay, now what would happen if the absolute value of the first number is smaller than the second number? Something like this: 1 minus 3 cosine theta.
It faces.
Okay, can anybody predict what the graph is gonna look like?
It's gonna face north.
Yeah, but how do you... Oh gosh, I give up. I'm going home. Okay, so let's do that. 1 minus 3 cosine theta. Man, graph it.
It's a circle and a circle.
So it's like a cardioid, but it has a loop inside it.
It's a moon.
Here, for those of you watching on video, here, let me graph it for you. 1, 2, 3, 4. 1, 2, 3, 4. See, I don't need polar graph paper. I just do like this, okay? So, here we go. Wait. I got it. Okay, that's ugly. There. That's better. Anyway, so it's like a cardioid, but there's a loop in it. Like that. You know what we call this? We call this a limosone with an inner loop. Or we can just call it by its nickname, inner loop. Okay, now let's do a sine one so you can see what it looks like. Exit. So how about we go 2 plus 3 sine theta. Graph. See? It's a cardioid. See, except this one, the loop is smaller, yeah? Okay? So, anytime the absolute value of the first number is smaller than the second number, you're going to get a cardioid with an inner loop in it, or we just call it an inner loop. Okay? Why don't you say inner loop? Okay, now, what's the last case? What happens if the absolute value of the first number is bigger than the second number? Something like this. R equals 3 plus 2 cosine theta. See, 3 is bigger than 2.
Does it like get it grown?
Can anybody predict what it's going to be?
Does it like have an ingrown?
A what?
Like a pimple kind of thing?
Say what?
I don't know how to, what's it called? Like a circle on the outside?
Ingrown hair, is that what you mean?
No, like a,
What is it called?
like
Three
growth. Is that
plus
like, is it like a
2
growth where it's
cosine.
a short piece on the outside?
Okay, I'm trying to concentrate here. Draw. Okay, now look at that. Whoa!
What?
So it's kind of like a blobbish, like a manapua.
It's a peach.
In PCH, we just call it the manapua.
It's a peach.
It's like a blob, a circular blob, except one side is kind of flattened out a little, like a manapua, right? We call it a manapua. And for those of you watching the video here, I'll graph it for you. See, you have to become the calculator. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Now, some of you might be wondering, Mr. Park, how do you know you're only going to need 5? Just think about it. The biggest cosine ever gets is 3. No. What's the cosine ever? The cosine biggest it ever gets is 1.
What are you talking about?
So, because the cosine graph looks like this. What's What's the biggest it ever gets? What's the smallest? So if the biggest this ever gets is 1, then what's the biggest r will ever be? 5. That's why I only need 5. So you guys are probably wondering, how do you know what? Okay, so then you, this is, I'm going to teach you the secret later. 3, and then 1. So it looks like this. This is what the calculator does, except it's really fast. Kind of flattens out over there a little bit. That's a minor part. See how it's like a blobbish shape? Manapua. So the books call this the blob, but since we're from Hawaii, I like to call it the manapua. And what do you think the sine one, what a sine one would look like? Then the flattened outside can be either up or down, right? So now let's look at that. Exit. So how about 4 minus, give me a number that's smaller than 4. 2 sine theta. So when the absolute value of the first number is bigger than the second number, that's when you get the blob or the manapua.
The window's too small.
Yeah, but you can just picture what it is. It's just like it's like you have a circular ball of clay.
And you smack against the table.
Yeah, and then you just dropped it very lightly on the desk, and then one side can be a little bit flat, right? That's what this blob thing is. Okay, now, how do you graph this? What, Mr. Park, can you give us the secret? Yes, I will. You cannot tell anybody else now. No, you can't.
It's on video though.
Charge them.
It's always the
Yeah, it's actually on the PCH video. Giving the secret. Yeah, but the other class is not going to know the secret. Okay, so here's the secret. You don't even have to know if the absolute value. See, like if the absolute value of the first number is smaller than the number, you get the inner loop, right? If the absolute value of the first number is bigger than the absolute value of the second number, we get the blob or the manapua. Yeah, but I'm going to teach you a secret. You don't even have to know this. But it's helpful. So here, let's do this. I'll give you 3 examples. What if you had r equal 2 minus 2 sine theta? Now, it would be helpful to know that it's going to be a cardioid, right? Because the absolute value of that is equal to the absolute value of that, right? Okay, but just watch and learn. The secret to graphing these limaisons is you plot the quadrantal angles. You just plot 4 points. What are the quadrantal angles again? 0, 90, 180, and 270. Now, if you want to draw the polar graph, if you want to get your polar graph paper now, you can, but you really don't need to, okay? So here we go. So basically, we're making a chart. Basically, this is what we're doing. We're making a chart like this, except we're only doing it every 90 degrees instead of every 30 degrees. That's what we're doing. Okay? And 360 is the same thing as 0, right? Okay, why don't we put 360 there? Okay, go. Plug in 0. Sine of 0 is... Okay, if we don't know our quadrantal angles, we're in trouble. What is the y coordinate right there?
0.
Okay, so if that's 0, you get 2. Okay, plug in 90 degrees now. Sine of 90 degrees is up here. What's the y coordinate up there? 1, so you get 2 minus 2 times 1.
0.
That's 0. No, you don't have to, hopefully you can just do this in your head. You don't have to make this short. Okay, 180. 180 is right there. What's the y coordinate? 0. So what's 2 minus 2 times 0? 2. Okay, 270 is over here.
-1.
What's the y coordinate there? -1. So what is 2 minus 2 times -1?
4.
4. And of course 360 is going to be the same as 0. So what you do is you just plot these quadrantal angles. At 0, you go 2 units from the origin. At 90 degrees, you go 0 units from the origin. At 180 degrees, you go 2 units from the origin. At 270 degrees, you go 4 units from the origin. And then of course 360 is the same thing as 0. And then you just connect the dots. Cardioid. So Mr. Park, you're telling me that you don't even have to know this. The positioning of the 4 points that you plot is going to tell you what the graph is. Yeah, that's what I'm telling you. You don't even have to know that. Just plot the 4 points and you're going to get the graph. Now, like I told you, if you want to use the polar graph paper, you don't have to though, because you're only plotting a point every 90 degrees. You're not plotting a point every 30 degrees in between there. So that's why you don't need polar graph paper. Okay, let's do another one. R equal 1 plus 3 cosine theta. Okay, before I even start, what?
Love.
No. Inner loop. If the absolute value of that is smaller than, you get the inner loop. But that's okay, you don't need to know that. All you're gonna have to do, plot the quadrantal angles. Now, do we need to make a chart like this, or can we do it in our head?
Do in your head.
Okay, let's see. Plug in 0. Cosine, here, look at the unit circle. Cosine is the x coordinate. What is the x coordinate right there?
1.
Okay, so what is 1 plus 3 times 1?
4.
Okay, so at 0 degrees, you go 4 units from the origin, right? 90 degrees, what's cosine of 90? That's up here.
Zero.
What's the x coordinate?
0.
So what's 1 plus 3 times 0?
1.
1. Hey, we can do this. Okay, 180 degrees. What's the x coordinate there?
-1.
Negative 1, so 1 plus 3 times negative 1.
-4.
No.
1 plus 3 times -1.
Negative 2.
1 plus.
Now, when r is negative, remember, you gotta go on the opposite side of the angle. So at 180 degrees, r is negative 2, so you gotta go 2 units in the opposite direction.
What?
You get, we learned that already. When r is negative, you go in the opposite direction of the angle. Maybe we do need to make this chart. 270 degrees. What's cosine of 270 degrees? What's the x coordinate right there? 0. So what's 1 plus 3 times 0? So at 270 degrees, you're going 1 unit from the origin. And then of course 360 will be the same thing as 0. Now, connect the dots in the order that you graphed them. Look. Inner loop, baby. Now, the only thing confusing for you guys are going to be, Mr. Park, I don't get this negative 1. Well, see, look, if this point was right there, you would have a cardioid, but it's not right there. So that's why, if this point ends up inside the other 3, you know it's going to be an inner loop. You get it? Okay, last one. No, you gotta do the roses after this. We're in trouble. Okay, how about 3 minus 2 cosine theta? Now, before we even start, what is the graph gonna be? If the absolute value of that is bigger than that? It rhymes with hanapua.
Manapua.
Chun, sit down.
Stretch.
No. Okay, this time we're gonna make the chart. 0, 90, 180, 270, 360. Okay, every 90 degrees. Okay, plug in 0. Go. Let's do this quickly. Lee. Have your answers ready. Just mumble something and maybe we'll take it. Just mumble something. Very good. 1. Cosine of 0 degrees is 1. 3 minus 2 times 1 is 1. Look, we did the 90 degrees, Garcia? Okay, so plug it into that, and what do you get though? Yes, this will be 0. Okay, 3. 180 degrees, Arita.
5.
Anoina, 270.
3.
And of course, 360 will be the same as 0, so blue. Okay, so at 0, we're going 1 unit from the origin. 90 degrees, I'm going 3 units from the origin. 180 degrees, I'm going 5 units from the origin. 270, I'm going 3 units from the origin. And then 360, go 1 unit from the origin. So, what do you have? Get the blob or the manapua. So can you see? I'm trying to teach you the secret. The positioning of this point is going to tell you what it is. If this point lies right on the origin, it's going to be a cardioid. If this point is inside the other 3, you get the inner loop. If this point is outside the other 3, then that's when you get the blob, or the manapua. But so the key is you got to plot these points correctly, otherwise. So this is the secret. This is like the fastest way to graph limaisons. You got to practice that. Okay, now we got to learn the Rose curves. Oh man, Oh, that's okay. What?
We start tomorrow.
Okay. Go sleep. You know, today is Mochiko chicken too, so the other class, we're gonna have to finish faster than this then. Okay, this is the last thing we're gonna learn. The Rose curves. Okay, this is the one where it makes flowers, okay? Okay, you know what? Since we're short on time, I should give you the secret already. Anytime you have r equal a number times cosine n theta, where n is greater than or equal to 2, or sine, a number times sine n theta, these are going to be Rose curves. And the number of petals depends on this number n here. So if n is odd, you will have n petals. If n is even, you will have twice as many petals. So for example, what if you have r equal 3 cosine 2 theta? How many petals are you going to have?
4.
You're going to have 4 because that number is even. You're going to have twice as many petals. Okay, let's see what it looks like on the screen. Okay, so what is it? 3 cosine 2. Oh, I gotta put parentheses. Full! How do you backspace?
Delete.
2 theta. Okay, draw. Yep, you got 4 petals. Okay, what about this? R equal 2 sine 3 theta. How many petals you gonna have?
3.
Look, if this number is odd, that's how many petals you're gonna have. Yes, you're gonna have 3 petals, okay? Let's see what that looks like. Let's just erase this first one already. So what is it? 2 sine, parentheses, 3 theta, close parentheses, draw. Hey. Now, do you notice that all the petals are equally spaced apart?
Yeah.
Yeah, and that makes it easier for us to graph. And what's the significance of this number in the front here? That's the length of each petal.
Oh.
So this number here tells you how many petals you're going to have. This number tells you the length of each petal. And they're always going to be equally spaced apart, but here's the hard part. How do you figure out where the first one is, Mr. Park? Like, is the first one always going to be at 0 degrees? Try look. No, it's not. So I'm just going to tell you the secret already. Save time here. When you have a cosine Rose curve, then you set this argument, we call this the argument, you set this equal to 0 degrees. You know why? The cosine of 0 degrees is 1. Isn't 1 the maximum value of cosine? Right? So that means at 0 degrees, see, this will become 1. 1 times 3 is 3. That's as far as you're going to be from the origin. That's where you're going to have the tip of the petal. So, when it's a cosine 1, you set this thing equal to 0. But in a sine 1, you set this thing equal to, what do you think? What is the biggest sine ever gets? 1. When does that happen?
90 degrees.
At 90 degrees. So you set this equal to 90 degrees. So for the cosine 1, let's graph. See, you have to become the calculator. If 2 theta equals 0, divide both sides by 2. What do you get? You get 0. So that means, okay, if I want to graph this one, the first petal is going to occur at 0 degrees. And it's going to be 3 units long, like that. So that's 1 petal right there. And then I'm going to have 4 petals in all, and they all have to be equally spaced apart. So how do I figure out when the next one's going to be?
9 degrees.
How many degrees are there in a circle?
360.
And if you have 4 petals, what's 360 divided by 4?
90.
So every 90 degrees, you're going to get another petal like this. So, oh, 1, 2, 3, oh, 1, 2, 3, oh. There you go. Equally spaced apart. But the key is you got to figure out where the first petal is. Noah.
What determines like
The length of the petal?
no, not the length, the width, like the.
Oh, okay.
Is that
Okay, it's hard to determine the width. You just look, I drew the pictures for you. Every year, there's always students making it super thin like that. No, they don't look thin. They're like kind of healthy like that, right? And they're not like really like that either, right? Like medium looking. We're just sketching the graph anyway. Okay, now, how do you draw this graph? Well, since this is a sine one, I set this thing equal to 90. So solving for theta, I get 30 degrees. Now, what does that mean? The first petal is going to occur at 30 degrees. Now, this one, you might want to use polar graph paper. Okay, 1, 2, 1, 2, 1. So, because look, okay, this is what the polar graph paper looks like. Because 30 degrees is marked off like that, right? So at 30 degrees, that's where the tip of the first petal is going to be, and the petal is 2 units long. It's going to be over here. Okay, so the petal looks like that. See, not too thin, not too thick. Okay, now there's 3 petals. They're all equally spaced apart. So what? What's 360 divided by 3? Oh gosh.
120.
300. Too late. 120. So every petal is going to be 120 degrees apart. So if the tip of the first petal here is at 30, where's the next one going to be? If you add 120. 150. So that's the next petal. And then so here's 30, 150. When's the next one going to be?
270.
270 over here. So see, so the fact that they're all equally spaced apart makes it easy for you to graph, yeah? You just got to figure out where the first one is, and then you get the rest. Okay, so that's all we're gonna do. So tonight's homework, you got circles, limosans, and rose curves. That's all you got.
It's not on the quiz yet.
Is it my fault?
I'm
Why am I gonna quiz you on something we just learned?
Just confirming.
How about actually do the practice quiz and then... Why would this be on? You're crazy! You want pop quizzes?
Don't do
I'll
it.
give you pop quizzes if you want.
Don't do pop quizzes.
Yeah, pop quizzes pop your grade, that's what happens.
Yes. No.